Okay, let's continue. So the MEMS market value, if you take a look into the MEMS market, the volume of the MEMS market value, and then you can take a look into the in detail, the area of the MEMS market value is kind of growing. For example, let's see over here, this is inkjet head, that the blue portion is getting glow, and then you see this violet, that's microfluidics for diagnostics. So that's the healthcare part. So those portion is getting increased, and then I believe still healthcare is the big deal in MEMS right now. Um, so there's many people in medical industry and the bioengineering industry. They are looking for the MEMS device that they can help patients now. So anyway, this is kind of trend. You can take a look into the until the 2012 at the time. Well, this is the top 30 worldwide MEMS manufacturer, right? I'm sorry, it's still is not updated yet. Um, But you see the first two company at the time, you see the Hewlett Packard and then Texas Instruments. So Hewlett Packard, they are a company making inkjet head, and then the Texas Instrument at the time was this is company actually fabricated micrometers for TV and then the projectors. Okay, STMC is the you know this company right now is they are um, boundary companies, right? They receive the orders and then they fabricate the devices for customers. So the foundry also is a big role in MEMS company as well. Bosch is the company in Germany. Actually, they are doing lots of MEMS fabrications, and then they also design their own as well, devices as well, including accelerometer, and then the uh, accelerometer is one of the the, uh, the pioneering work done by the Bosch, because they also actually they developed also the process called the Bosch process is to making like a bulky um, uh, mass for the accelerometer or gyroscope. They developed certain unique MEMS process, and then they put the name like a Bosch process. And then the Canon, that's inkjet head, so on. So those are kind of company. So I wanna probably the trend of today is not the same as trend of at the time. Uh, but this is kind of the good name of the company that you can start to take a look into the what is out there. Okay, so at the end of this lecture, you're gonna given like assignment, and then to take a look into the website and to see the products out of the MEMS, and then they read their spec sheet and then um, present at the classroom. So just be prepared those homeworks. Okay, that's the top 20 MEMS foundries at the time. So the number one was the STMC. That's I just talk about it, and then the Texas Instrument and so on. But uh, and the MEMS cap over here, that's the usually I use for my project. I send my design to the MEMS cap here. So those the boundaries is very important because the fabrication facility is very expensive to establish. Okay, so it's not possible for the like a small MEMS company to build their own fabrication facility. Okay, so those the fabrication capability outside as a foundry, that's important to push out the product through the design by the uh, the MEMS companies, and then built by the startup, built by the foundries, and then the product could be available to the market. So those foundries is very important to be survived to, to support the MEMS industries. Okay. Okay. So again, the kind of summarize the like brightest spot in MEMS industry, like MEMS accelerometer was good in 2013. Gyroscope was good for the like consumer application, like a game company. And the MEMS microphone now is more, everybody using MEMS microphone now rather than the old traditional microphone. So, I mean, iPhone was the first one that adapted the MEMS microphone in their system. After that, every cell phone company started adopting the MEMS microphone. And then some other things are also available. So that's kind of a good side. And then I believe, this slide skipped the healthcare side, but now healthcare is more dominant market, I believe. Okay, then the question is why MEMS is important, and then why people using MEMS. Okay, so this kind of slide kind of summarize why MEMS is useful for some applications, right? So overall, MEMS is small size comparing to its traditional counterpart. Okay, and then weight is also light, and then it is possible to integrate with electronics. Okay, so that means, right, it is kind of portable. It is a small size, portable, and then depends on materials. It could be implantable as well. You can put this MEMS device into the body, to check the pressure of like a human's heart. That's also implantable, right? It's implantable because it's light and small. Otherwise, it's not possible. Also, because it's small, their power consumption is low. Okay, and then the less sample is required as well. That's what the healthcare side they wanna push microfluidics, because you don't necessarily to you still in hospital. I was stopped by a few weeks ago to check my kind of a blood test, but they still take it out bulk, lots of blood from from your vessel. But I mean, still you don't need that a lot. If this MEMS biochip is available, they need just small couple of drops, and then test could be done. Then, I mean, this is still the sign that is not commercialized yet. I mean, traditional way is still used in hospital. Also, is in micrometer scale. So that's good size. That's good. That's why the MEMS is good. Also, the way to make the MEMS is using batch process that borrowed from the IC fabrication. Okay, if you're familiar with IC fabrication, we'll talk about this fabrication, a few weeks later. But I mean, this is a batch process. But each batch process is very simple, right? You design certain mask, and then you have wafer under the mask, and then the mask, there are certain pattern was already designed, and then through the it's called the lithography process, and then usually UV light used to pass through the mask, and then those pattern was copied into the wafer, and then developing and other processes could be done, and then so the pattern designed on the mask was kind of copied onto the below the silicon wafer. So that process is really simple, and then easy, and that's why it's low. So those batch processes is proven to be very low cost fabrication technology, right? So that's also advantage for the MEMS. Okay. Also, and then it could be better performance. We have a better control of the geometry and then purity and properties, and so as a sensor, it could be more sensitive, more accurate, right? So those performance is outstanding comparing their traditional counterpart. That's why the MEMS is useful uh, comparing the other uh, system, right? Also, the high surface to volume ratio, that's also important because in small scale, in small scale, even though because you can imagine that, right? That there are many, for example, some surface, right? You printed certain surface with some wiggles, very small scale, okay. Then comparing with the volume ratio, volume of the pattern and then the surface area is much higher because those wiggles is very small scale, very not like a few nanometer scale. Then the surface area is really huge comparing the just a macro counterpart. So those high surface areas can helpful to increase like sensitivity of the certain reaction. Okay, so those things are that's why the MEMS have advantage over the conventional counterpart. So those application is used for those advantageous uh, technology in the system. Okay, so regarding the MEMS future, so still, we need a more killer application. There are some success and then there are some failure, but we need a really high volume application is also we are still looking for, right? Um, that's another part, and then um, the biomems and the lab on chip. That's as I said, that's healthcare section. Those has high demand, right? Still, many parts should be improved. Also, the microfabrication infrastructures is already is out there. So if you want to like start your own startup for the MEMS company, then you don't necessarily worry about fabrication. You just focus on your design and then send the chip design to the foundry, and then you can do business. You don't worry about the microfabrication at the moment. So right, so that's a good sign. And then by combination of nanotechnology and biotechnology into the chip, actually you can have a more business available. So that's a good side of the MEMS picture. Okay, if you want to have more information about MEMS, there are other books available other than the Professor Centuria's microsystem design. Um, the micro machine transducer source book, and then the MEMS handbook, fundamentals and application of microfluidics, and those are the early pioneers in that area. So I believe they have a more updated version available right now. So those textbook kind of Bible in this area. You can have more insight from the books. Also, the journals are available to read to know what's going on right now. I recommend to take a look at the journal of MEMS and then sense and actuator in A and B. A is the physical sensors and the B is more chemical sensors. Or journal of micromechanics and microengineering on lab on chip or other journals like some high impact works done also fabricated in uh, micro nano engineering published by Science, and then the Nature uh, published by Nature. There is a scientific report, and then some good application also published in either Nature or Nature Com or Nature Physics, right? Uh, So those things are the journals you can take a look into. Okay. Also, there are several conferences available in either every year or every 2 years. Okay. The transducers, I believe, is every 2 years. Uh, that's about mostly about the MEMS, and then uh, the MEMS conference is every January. Um, so there is MEMS conference. That's good conference to make. Hilton Head conference is only for that's Hilton Head in the United States is, I think, is South Carolina. They have conference over there. There are more focus on. Uh, they actually invite either government and then the commercial consumer as well. So to bring the scientists and then their demander, they kind of sit down together to take a look into this, discuss more detail about the application and future of the MEMS, and it's mainly for the North America people, but still you can make it. And microTAS, that's the more applicable to the bio MEMS area. And then the ITV sensors, that's also good conferences, but they also including other type of the sensors as well. So it's not only for the MEMS, but they including the other sensors. Okay, I made transducers, and then the MEMS conferences, and then the ITV sensors recently, and then my personal experience was really good. So I strongly recommend to take part in these conferences. Okay. Okay. So general approach to map design. Um, when you design your MEMS, and then your target, why you design the MEMS your device is maybe various, right? Um, the authors actually they divide into like three categories. One for the technology demonstration, right? This is most of the school, like you, um, um, they have some idea and then they want to demonstrate, right? So they kind of design something and either they fabricate it by own lab or send the technology design to the outside and then fabricate. So those are things that you want to demonstrate your technology. Or some people develop the MEMS for like a research tool. They kind of I remember some people design certain small scale like a tensile machine in MEMS scale, and then they deposit certain small scale thin film in the MEMS, and then they kind of stretched out. So in that way, they can do some tensile testing in very small scale. So those things are the MEMS was used as like a research tools, right? So that's another part of the MEMS. And then the commercial product is available like inkjet head and then MEMS microphone and so on so on. So depending on the level of your devices and purpose of the devices, those are the area that you can kind of categorize it. Well, depending on the high-level design issue, right? At each categories, right? Technology demonstration and research tool and then commercial product. So you can kind of how much they are kind of mature at each like level, like in market, right? In technology demonstration level, you don't really not care about the market at the time, right? At the level, because you want to demonstrate, right? So you more care about the impact and then technology level, right? Rather than the other three, right? You don't worry about how to fabricate, how to manufacture it, right? In batch process at that time, right? You want to demonstrate the first, okay? For in the other hand, the commercial product is market is more important, right? you try to build these devices to sell, right? So market is, it should be available. You should produce the MEMS devices that you can sell. Otherwise, you're gonna lose money, right? So actually, the commercial product level actually, this product care all five aspects of the uh, importance, right? Manufacturing should be perfect, and then the technology level should be high, and those high competition, high impact, and then right. So it's a commercial product is a really big deal. Right? At the same time, to get to that point is it takes time as well. Um, so yeah, it's a big deal, but at the same time, need time and then effort to get it done. Okay, so basically, this is kind of a overview. You have like you have think about those creative thinking, and then you wanna check those idea with the modeling analysis, and then you can improve your kind of concept, right? So those are like a process you kind of feedback, and then in this creative thinking, you are consider many things at the same time depending on your product level, right? At school level, you want to have more technological capabilities more important, right? So those things are the kind of integrated into the design of the devices, and then double checked by the process analysis and modeling. That's the process. Actually, we do intuitively, you know, right? So, but when you get some design done, actually you can kind of double check whether your design makes sense in those aspects, right? Whether your idea is great, is good, but is it really possible to make? That's kind of good question sometimes, right? Okay, how about the modeling level? Actually, this is very interesting figure. Actually, I mean, we usually think about our device in physical level actually. So our way of design is not the way as shown here, because when I'm asking you design of certain maps, then actually you design from like a physical level, and then after knowing the process, actually you get to know how to make the MEMS product, MEMS device, then you design based on the process the buyer able to make that devices. Okay, and then after making certain MEMS devices, your level of sense, the level of devices getting higher. Like at the end, you have system level. Like a system level means you have sensors and you have maybe some IC chips, and then you have certain, some input-output way to consumer. So those are completed system, and then between the two, you have all the device level, right? So there are some steps between the two, okay, and then that's kind of your modeling level also is getting to simple model, getting to higher level, higher, and then more complex level. For example, in physical level, you design certain cantilever, right? You design certain cantilever, but in device level, because you integrate with the other circuit design, and then so analysis level is getting complex, then you may need some simplified model for the cantilever, right? That's really happen in the simulation level. So instead of making like a continuum continuous motion, you kind of select certain node and then the masses, so you can kind of simplify it. That's enough for your device. Then you kind of save your effort and the like size for the physical model itself, and you have a more focused on the all the process. So that simulation and the verification level will become different depending on the modeling level. Okay, all right. So, well, if you take a look at expanded view of the modeling analysis, that's he kind of put them together. So don't worry about too much on this. But usually, I mean, as a graduate students at school, we more focus on the physical modeling and then the process, and then eventually when you move to the company level, you more focus on the device and system level later. So in this class, we more focus on the physical and then process level rather than higher level, because we don't know this level yet, so it's very hard to handling the device and system level. So we more focus on this low level. Okay. Okay. So it's really not why I don't know really why this coming at this point, but control is also important part of the system. Um, in system level, in certain device you need to have good control of the system, and then every measurement has a certain control. So those control we'll talk about this later, but this is important part of the system as well. Okay, I know it's kind of early, but I want to give you some assignment. If you have chance to take, have the book, and then please read chapter 1, 2, 3 in advance, and then the homework number 1 that's due in 3 weeks, I believe, right? Or 2 weeks, right? Problem 1.2 and 2.2 in the textbook, and then the I may kind of posting what is problem 1.2 and 2.2 in the textbook, but I'll let you know, right? And then the other homework is visit one MEMS manufacturer's website shown in the slide 10. Actually, it's not the slide 10. That you remember the slide that I showed, Hewlett Packard and and some other company that's showing the product of the MEMS, right? So pick a MEMS product from the company, okay, and then the print and understand is a spec sheet in the report, and then bring some copies of the spec sheet, and then we'll share together in the classroom. So March 31st, if we meet at the time, and then I'm going to share, you are going to present what you found from the website, and then you kind of present and share each other. Okay, so you don't necessarily to prepare any formal presentation, just to bring your copy and then share that, and then just briefly talk about it. Okay, so again, I'll let you know what is problem 1.2 and 2.2. Thank you very much.